Hello CIS40A, this is part 3 of the lecture video, and in this video I'm going to go over cabling. So there are 3 main types of cable that we want to focus on in this particular chapter. The first is going to be coaxial, second is going to be twisted pair, and third is going to be fiber optic. Coaxial, this is what you normally see especially when you work with cable company like Frontier, Spectrum, etc. And it would be the cable that I would refer to that where it would have a center core that looks like a needle. So a coaxial, it would have a center, what's called a conductor, that is surrounded by the plastic jacket, and there will be braided shield wire mesh that's around it. So here it gives you the material that goes into the coaxial cable, and it's very commonly used even in today's world. So there are 2 types of coaxial. The first is going to be thin net or thin Ethernet, and this is a 10-base-2. As its name, thin coaxial cable is known as thin net, and so the millimeter for the thickness really indicate the type of coaxial. So thin Ethernet cable is a radio grade 58, which uses the connector, so its connector is RG58. You don't see many of these anymore because we have better coaxial cable now, but if you do work with some older type of network or systems, you would see RG58. The 10-base-5 is considered to be a thick net or the thick Ethernet. And as its name, we would see that this would be the thicker in diameter, and also you can run the coaxial up to 500 meters. So for the center core is of significance in that it would determine whether it is a thin net or thick net. So way back when, we would then be able to use coaxial for a lot of interconnectivity, and now currently I think a lot of the residents still use coaxial to be able to connect. Now these connectors are used for coaxial, and they are referred to as B and C. You would have a female, or we would have a male. Often you would see more of a male, and sometimes you might be able to extend it using the female. So this chart gives you the rating for the RG, which pertains to the connector, and also different ones will be used for the type of coaxial. And the type of cable is usually copper, and because copper is the cheapest to be able to implement. Next, I'm going to talk about twisted pair cable. So your Ethernet cable is a twisted pair cable. After you remove the jacket of it, you would see that the copper wires are twisted together, hence the name twisted pair. We would have an STP, which stands for shielded twisted pair, or we can have a UTP, which stands for unshielded twisted pair. The shielded twisted pair would have a layer of foil, and that foil is used to be able to protect from interference, from elements, and so on. And the unshielded twisted pair, this is your common Ethernet cable. So when you remove the jacket, you will not see a foil wrapping. So that will be a UTP. And this is used in 10 base T, 100 base TX, and 1000 base TX. So whenever that you see the value in the front here, 10, 100, and 1000, that pertains to the speed. So, and T or TX stands for twisted pair. So you know that that's the medium. It's definitely affordable to implement or to use STP or UTP compared to other form of cable like fiber optic. It's really easy to work with, it's cheap to implement, and the transmission rate is mostly reliable and fast. So when do we use the crossover UTP? The crossover UTP is used to connect the same type of devices, like a switch to a switch, a computer to a computer, a hub to a hub, and so on, where we can make a straight through UTP. That means that both ends are the same. The connector, the way we wire it, that will be exactly the same. That would be used to connect one device to a different type of device, like a computer to a switch. The crossover UTP, one connector is different than the other, how the cable is crossed, or the copper is crossed within that connector. And crossover UTP is used to connect same type of device. So there are rated categories. We commonly see Cat5e, so that will be used in a lot of networks. We started to see more Cat6, Cat6A, and Cat7. Because as we move to the later category, you see that tremendously there is a change in the speed. But for UTP in general, you would the maximum length that you can pull the UTP cable is 100 meter. Some in general, some would be higher at certain frequency, like Cat6A, compared to the older categories that will be 20, but much less. So to answer our question in our assignment, for number 19, you can refer to thin net and thick net in the coaxial section, and you can include that for your answer. You can summarize that. For number 20, it asks you to identify the types of network that uses STP cable. So that will be a 10 base T, 100 base TX, and 1000 base TX. The frequency for Cat5e and Cat6, you can find that in the notes on page 14 in this section here. And as you go through it, you will find that Cat5e and Cat6, Cat5e is at 100 Hertz and Cat6 is at 250 Hertz. So as you remove the jacket for the UTP or the STP, you would see it's twisted like this. You would have a solid color, and they follow the color by standard: orange or orange stripe orange, green stripe green, brown stripe brown, blue stripe blue. Okay. Now the RJ11 is used for telephone, where the RJ45, this is the connector for Ethernet. This right here is where we would want to push our copper in, and it needs to touch the conductor here in order to send signal. So when you untwist the wire, you would then insert each of the wire into these slots. The line right here is going to be the crimp line. And so when we use a crimper, that's going to press down onto the plastic jacket of the cable and keep it in place. So the way that we would use the for insert the wire, we would use the color scheme. And we want to follow a certain standard. And so in the lab this week, you will be able to, on Thursday, you will be able to create cable and test the cable. Next, I'm going to talk about fiber optic cable. So currently, fiber optic is the fastest medium that would be available for networks. And it uses lights rather than electricity signal or electrical signal. The benefits of fiber optic would be that it is immune to interference and it can transmit much farther, about 25 miles. So when I need to connect one building to the next building and there are maybe a few miles apart, then I want to use fiber optics. If I care about data transmission, reliability, and also fast speed. The disadvantage of fiber optic would be that it's difficult to install. It requires special knowledge and skills from a fiber optic technician in order to do that, and they're usually certified. It's much more expensive than the twisted pair, but as now the price has gone down due to the demands for it, and there are more supply for it. So to really identify the type of fiber optic, we would have a single mode fiber optic cable, which is your SMF. This is a high speed single strand, sometimes double strand, and it would have glass fiber to carry the signal. It uses LEDs and laser. It can be 50 times faster than the multi-mode fiber, which is the second type that's listed there. So for the multi-mode fiber optic cable, the light is dispersed into different paths that it's going to travel. Multi-mode provide high bandwidth, high speed, and it can go up to 3,000 feet. So single mode is faster than multi-mode, but the distance for it is not as lengthy. SMF can be used between buildings, where MMF can be used across cities or towns. Here are some images that can show you how that would look like. And going back to our assignment, it asks you for the difference between SMF and MMF, single mode fiber and multi-mode fiber. You can take that section or you can summarize it to provide your answer. Then we're going to talk about different features and components of fiber optic. So when we look at the fiber optic cable, we would also pay attention to the type of connector that it uses. So the angle physical contact, which is your APC, compared to the ultra physical contact, which is the UPC. And there you would have a picture of those. So the ultra polished connector would then be utilized. So for example, the angle polish connector that's shown there, that won't be suitable for the angle cut. So you would have to use UPC. So here it talks about how the light is reflected back to the core of the fiber, which cause loss in dB. Okay. Then you have connectors that are called straight tip, which looks like the image below. So your ST fiber connector, this is created by AT&T. And it's designed to be able to connect and disconnect quickly. Another connector is also known as the SC, or subscriber connector. This allows the connector to be securely stay together without falling out. So this is what you see. And a lot of the electronics components like sound, you would start seeing a lot of the SC being used, like in sound bar and so on. The mechanical transfer register jack, your MTRJ, is designed by AMP, and the local connector, your LC, is designed by Lucent. So the MTRJ connector is used for smaller form cable. And here it gives you a little bit of information about benefits and also its characteristics. The LC, which is a newer type, and it's would then commonly be adapted with fiber channel adapters. So with the cable for the fiber, you would have fiber distributed panel, your FDP. That's where the fiber cable would then be connected to a distributed systems that would consist of tray, splicing drawer. It's really designed to connect the offices together using the fiber in the facility. So for the next question, it asks you what is FDP, which is fiber distribution panel, and we just went over that. So you can refer to the notes on page 18 to obtain the information for FDP. So here's a picture of your fiber optic transceivers, and it can be unidirectional or bidirectional. And unidirectional, we call that a simplex, and bidirectional, we would refer to that as a duplex. So here it touches on the characteristics of bidirectional compared to unidirectional. And then we have other media. USB is commonly used. There's talk that USB 4 will be coming out. So right now we're at 3.2 with the Gen 2. And then right below that, I included an image for your cables. So there's USB A, B, B mini, micro, C, and Lightning. In the next part, lists the FireWire, which is IEEE 1394. Make sure that you know that for certification and for quiz and test for this class. Was designed from 1980s. Apple, Sony, and Texas Instruments started using the FireWire way back. that shows the end connector for that. Then we also have power line networking, where the device is connected to the electrical outlet, and that will be able to connect them to the larger part of the network. Then we have broadband over power lines, your BPL. This is for high-speed data transmission, and it uses higher frequency, wider frequency range. So for the questions, you can refer to the notes to answer number 24, which is broadband over power line. And for the notes, we would then look on page 20. Then it goes into HDMI Ethernet channel. So that's a combination between the Ethernet cable into the HDMI, and that allows some transmission there. Then we have Docsis, which is data over cable service interface specifications. This is now in its 3rd generation. That allows high bandwidth data transfer using coaxial cable. Then we also have fiber optic media converter. This is an appliance like the picture is shown there. It's used to convert certain part of canvas into something that would be certain part of media, certain type of media into something that would be usable. It can convert the files. It can also interconnect fiber optic. Now, access methods are essential. CSMA CD and CSMA CA. You will likely get questions on Network Plus certification relating to this area. So CSMA CD is a carrier sense multiple access with collision detection. CSMA CA is carrier sense multiple access with collision avoidance. So the CD is for detection, the CA is for avoidance. Now, collision needs to be detected, and alternatively we can use CD, where CA is unreliable due to if we run into a hidden node problem. But here it gives you the general information about and the comparison between those two. So to answer the next question, number 25, we want to explain the difference between those two, and you can refer to the note, page 22. Next, we're going to talk about modulation. And modulation simply is a way to encode electrical signal that would be transmitted over the medium. It could be wireless or wired. And modulation is a form of digital to analog, using digital to analog converter. So there are a lot of things that we use today that already have this built in. For example, the smartphone is one of them, where you talk on the phone, which is an analog signal. It then would be converting to the digital. When it transmits, it's going to transmit as packets and digital, of course. And then when it gets to the destination, to the device that's hearing your voice, your friend that you're calling, then it's going to get converted from digital to analog to give the voice, your voice, so people can hear it on the other line. So there are three types of modulation. We have the AM, or primary, three types anyway, AM, PM, and FM. AM stands for amplitude modulation. FM stands for frequency modulation. And PM stands for phase modulation. And there you can see the differences across those three. They are specific to frequency and how it's transmitting binaries. So for the next question, we can say the type of modulation is AM, FM, and PM. For 27, it asks you what type of cable is used in a 1000 base LX IEEE 802.3Z. And so when you don't see the TX at the end, we know that it's not a UTP or a twisted pair, a TP. So when you see LX, that is referring to fiber single mode. So how do I know that? Where can I find the information on that? After it talks about TDM, which is time division multiplexing, it's a way for the system to transmit and receive independent signal. That could be digital or analog signal. And then demultiplexing is a technique for the bandwidth to communicate with the medium that divided into the series of non-overlapping frequency bands. So baseband transmission uses digital signal over the wire. And when you're looking at fiber optic, then that will be pulses of or light, where if it's copper like coaxial or twisted pair, then that would just be electrical pulses to represent the digital information. We would have broadband, and broadband transmission would use digital signal, or it uses analog signal in the form of optical or electromagnetic wave over the transmission frequency. Fast Ethernet compared to gigabit Ethernet. Fast Ethernet transmit at 10 megabit per second, where gigabit Ethernet transmit at a much higher rate, gigabit per minute, or per second, I'm sorry. Earlier I mentioned that there's some information for 802.3, so you can find on page 24 lists a group of 802.3 different type of base. So remember what I said, the number in the front represents the speed, then it would represent whether it's broadband or baseband, and then it will represent the medium by T, TX, LX, CX, etc. So here gives you the comparison. And then the following table on page 24 shows you the topology, the type of cable, the type of network architecture, access method, and transfer. So in the network architecture, we would have the network architecture, the type of topology that you would implement, the cable that you would use, how fast that's going to transfer. That's depending on a lot of different areas. That's what we just listed. So for the next question, it asks you to look at network information services. And as we get to the last part of the lecture here, it goes into network operating system, which is your NOS. So a network operating system could be your Windows Server operating system. It could also be your Cisco iOS or Router OS, depending on the appliance that you use there. And then you also have FreeBSD, Linux based, and customized based on specific purpose of your network devices. So the last part of this is addressing Unix. And Unix was a family of multitasking, multi-user computer operating system that's derived from AT&T Unix. And it gives you a little bit of history behind it. So in the last section on page 28, you will find our number 28 answer. Network Information Services, it is a client server directory service protocol. It's used for distributed system to maintain data configuration files in the network. And it is a way that we would use it for distributed naming services. We would use that to locate a certain system, devices, resources, files, objects. It would store it uniformly and also be quicker to be able to retrieve. So we can include that in our answer for the last question. Describe the purpose of NIS. Make sure we know that for the final exam and also for certification. At this point, you can then save your document with your question and answer, and you can submit it in week 1 assignment or unit 1 assignment. And that covers the network concepts that we have for this week. Please let me know if you have questions. Thank you for watching the video.